We're going to continue on with working with the graph data structure, and to do so, we're going to look at the actual traversal settings. So over here on this side, we have our data structure itself, our graph represented. Over here, we have our graph data structure. It's represented with this lovely little image right here with our nodes starting at 0, 1, 2, 3, 4, 5, and 6. As you can see, we have some directed connections going in blue from 0 to 1, 0, 2, 0, 3, 0, 4. 4 goes to 5 with a bidirectional connection, and 2 goes to 6 with a bidirectional connection. So we have an undirected connection between 5 and 6, and we have an undirected connection between 4 and 5, and then directed connections between 0, 2, 0, 3, 0, 1. Okay? Pretty easy setup right here. The associated graph data array, the link to the string objects we're actually storing right here is from going from 0 to 6, aka a 7 structured array right there. And then finally we have our lovely adjacency matrix, the Boolean 2D array of values that show where things are connected. As you can see, we have in row 2, column 6, we have a true value, which says that C++ is linked to the asterisk operator, aka the dereference operator that we had stored in there when we did that first part of the code. So we have that connection right there. We take a look at the corresponding one in row 6, column 2. Oh, look, it's a bidirectional relationship. So row 6, column 2. So that's a bidirectional relationship, which we see right here with that purple arrow, making that connection between those two things. So we have an actual connection with that. So what we're going to be doing with this is we're going to take a look at the actual traversals that go along with this. And in the traversal section, as you can see right here, I have my connect words, which is my name of my graph that I was working with, and I have my dot breadth first traversal passing it the connected words and 0 from the index we're going to start with, and then connect words, and the depth first traversal passing again the graph and the node we are starting with, in this case, or index we're starting with, in this case again 0. Over here on the left-hand side of the board, I'm having a couple of bits of information right here, so make it so you can see this a little bit better here. So right here we have a space right here for the set of connections, aka our neighbors we're going to be looking at for this. We also have our vertex queue. This is going to be the queue of locations within the array that we've looked at as we're going through and doing the iterative traversal for the first one. And then finally we have our array of booleans visited, which by default are all set to be false. Again, you can take a look at the code that goes along with this, and we'll have it showing on screen here in a bit as well. But we have that code that we'll be using to actually go through and make this traversal happen. So these are the structures we actually have to get set up in order to do this when we do the actual traversal of this array, or excuse me, of this graph that we've already built. So we're going to look at the breadth first traversal, the iterative traversal, and so that's why we have that lovely queue right here. We're going to use to keep track of the pieces. We'll add to the front, remove from the front, just like a regular queue is set, or add to the end, remove from the front, just like a queue is set to do normally. And we'll be using that structure to actually have that happen. And so that's what we're going to be building here with this today. So let's go ahead and let's take a look at the actual structure, what we have to do for that. And so we have within our depth first traversal, we have our breadth first traversal. So the first thing we have to do is we have to go ahead and assert that the vertex we're looking at is within size. And since I'm passing it 0 and we have a size of 6, we're totally good to go. The next thing we have is we declare our Boolean array called visited. And right here we've initialized all of them to false using the fill end method as part of the standard library. So we have all of them right there ready to go. We have our set of connections, which is a set of values, which we're going to use multiple times. We'll reinitialize that value as needed. But it's a set of ints. We're representing the integers right here inside the positions of our graph data. Each of those locations are the ints we'll be putting inside the connection structure. And then we have an iterator we'll be keeping track of, and we'll be using a little pointer to say, hey, oh, that's where I'm pointing to right now for that. And then we have our queue, vertex queue, right here, the queue we're going to be using to actually build that structure. So when we're looking at what we have to do, first we have to get those basic components pre-built in advance before we go into the code. Or not before the code. Once we begin the code, then we're going to go into the rest of the method and actually go through and do that. So the first thing we have to do is we're going to go ahead and start the first vertex, in this case 0, the one that's passed as a parameter, and we're going to set that to be true. So we're going to erase that false value because we're starting off with a default value of false for everything on there. And we're going to change this to be true because we have now visited that 0th spot. That first spot in the array is the first thing we're looking at, so we're going to change that value as our first step. The next step that we have when we're going through this is we're going to go ahead and add that to our console. So we're going to go over here to our traversal console, and in that console we're going to put the one that we're traversing. In this case, we're going to print out the contents of that, and that is computer science. So it's going to say computer science. And it presses an enter, it's an inline, so it's going to go to the new line, and have that go from there. So we've got that happening right there. So the first thing we've done is just immediately traverse that first location. We're here, we've used it. And again, this is the breadth first. We're going to go as wide as we can and then go from there. So we've got that in. The next thing we're going to do is we're going to push that vertex onto the queue. So we're going to push onto the queue. So here it goes at the end of the queue over here, and we're going to add 0 to it. 0 is at the end of the queue because it adds to the end and always removes from the front. Right now it's a 0, but that's okay. No big deal. Or size 1, actually. No big deal. Now we then have our loop check. Is our queue empty? No. No, our queue is not empty. It has 0 in it, so we're okay. We have to keep on going. So the next thing we have to do is we're going to go ahead and set connections. This lovely set right here is going to be the neighbors of what's at the front. We're not going to remove it from the front. We're just going to look at the front, look at it, because we're not going to dequeue it. We're going to look at the front and get its neighbors. So we're going to go over here and use the neighbors method. And the neighbors is going to return everything that it's connected to. So we have the 0 queue, and we have connected over in the 0 queue by looking through that adjacency matrix. We see that 0 has neighbors of 1, 2, 3, and 4. So we're going to go ahead into our connections and add those lovely components into it. So we're going to add 1, 2, 3, 4. And because it is not a reflexive or a undirected location where it has a loop on it, we don't have to worry about that. We don't have to worry about adding 0 to this because it's not a neighbor with itself. So this is the connections that are attached to our 0, the first thing in the queue. And so we have that ready. The next step we're going to do is we are going to take the queue and we're going to pop that queue off. So we're going to remove 0 from the queue. So right now our queue is empty. That's okay. We're going to keep track of that. So the next step we have is we're going to use a for loop. We're going to iterate over the connections the connection set. And so we're going to start that out with the connections at the beginning, go until we're not at the end, and we're going to go up by 1 each time. And so we're going to go over this lovely set of connections right here, and if we have that connection, if that dereferenced operator at this spot, if we go look at that lovely spot down here, if it's not visited, we're going to go ahead and grab stuff from it and do the next set of actions. So the first one we have inside that, we're starting iterator off of that first location. Beginning is at 1, so we're going to look at that. So we look at 1. We then look at the lovely visited array. Is 1 true? No, it's not. Okay, fantastic. So it's false. So we're going to go ahead and we're going to say visited subset iterator. And we're going to set that to be true. So we're going to change that value. It's going to be true. Our next step is to go out to our console and add that to it. So we had computer science. Our next one is data structures. So we're going to add data structures to our console. We've put that on there. And we're then going to push onto the vertex queue the set iterator that value right here. So that 1 is going to get pushed onto the vertex queue. So we're going to add 1 to the queue. And so that's the first step that we did. So that's on the queue right here. It's at 1. It's added to the end. And the end right now is at 1. And my marker is dying, so we're going to switch gears here. Since nothing's in the queue right now, we're just going to add it right here at the front. So we're going to add 1 right here. It's added to the queue, ready to go. And then we're going to go to the next spot in the iterator, which the next spot is 2, because it goes iterator plus plus. So we're going to move up in the iterator. We're going to 2. Is 2, have we visited yet? No, we have not. Oh, okay. So we're going to change this right here, and we're going to change that one to be true as well. So the next step after setting that to be true is we're going to go over to our console. Our second option is C++ pointers. So is C++ pointer is our 2 option inside our data structure. So we're looking at graph data, dereferencing the value that's stored inside that, and putting it to the console. Okay, fantastic. And then we're going to push the 2 onto the queue. So the 2 is going to go in queue itself, so it's going to go right here. And it's going to go after the 1, because again, we're going to go after that, because we are adding to the end of the queue. And then we're going to go to the next one in the queue. So the lovely pointer has moved starts off here, and then moves to here. We're going to then go to next again, and the pointer is now pointing now to 3. Have we visited 3 before? No, 3 we've not. So we're going to go ahead and we're going to change that to be true. We're going to go over to our console, add what's at 3, and that's Java rocks. We're going to come back over here. We're going to take then, after doing that output, we're going to push that onto the queue. So we're going to add 3 to the queue, so we're adding that third spot on there. We're still not at the end, so we're going to move our iterator, moving to the next stop, which is 4. Okay, 4, have we visited 4 before? No, we've not. So we're going to change 4 to be true. Go over to the console. 4 is the, what was S? Oh, 4 spot is Swift is nifty. So we're going to go Swift is nifty. Output that to the console. We're going to come back over here. We're going to put 4 onto the queue. Okay, we've got that. We've added up there. We've now gone through this for. We're outside of this. We've exited the for loop now because we've actually at the end. We're no longer at the end of by ++ing, so we've reached the end of that set. So the next set of instructions that we need to do is we go back up into the while loop, and we're going to check to see, is my queue empty? Oh, no, it's not. So the next thing to do is I need to go through, and I need to say connections. I'm going to grab the front one. I'm going to grab it. I'm going to set connections to be 1's neighbors. So we're going to go over here. I'm going to look at 1, and 1's neighbors, as we look at the structure, nothing, 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 nothing. 1 has no neighbors. We have an empty set. So we're going to go ahead and say our connections is an empty set. The next thing we have to do is after we do that, we're going to take off the first thing in the list. We're going to pop off that value, that 1. That takes it out. So now our queue is 2, 3, and 4. Because we've popped the 1 out because we've gone and looked at that. We're going to go then look at the lovely iterator, starting at begin, going to end. Oh, look, there's nothing in that set, so it's just going to immediately get out. We're done with that. Fantastic. That loop is fast, easy peasy. So then we then go to our next step. We come back to the while loop. Is our queue empty? No, it's not. So we're going to go get 2. We're going to get the neighbors of 2, so we're going to go over here, and we look at 2, its neighbors. No, 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 no. Yes, we have a neighbor at 6. So our connections right here get 6. It's the only listing within that set. We're going to then go ahead and we're going to go to sub 6. Have we visited 6 before? No, we've not visited 6. We're going to change that right here to be true. We're going to print out the contents of 6. In this case, it's the dereference operator. So we have the asterisk is the dereference. We print that out. We're then going to come back up. We're going to push 6 onto the queue. So 6 is going to go right here after 4. We're good to go. And then push that on the queue. We come back up. We're going to look at the rest of that. Oh, we're out of there. So it means we're out of that for loop. We're going to go then back to our queue. Is our queue empty? No, no, it's not. So then we're going to grab the front item of that. And we just, we had queue right here of, we took 2 off because that was that connection. So we actually took 2 off right there because that's how we got 6. Excuse me, please. And so we took 2 off at that point, and we're going to go to 3. We're going to go to 3's row. And 3's neighbors are an empty set, so that empty set is nothing. So the loop iterator for this is going to go from 0 to 0. No big deal. That loop is done and over with. We go then back down to our next part of the loop. So 3 gets popped off that lovely queue. We look at 4. 4 is our next spot in the queue. Okay? And we are then going to grab the 4's neighbors. 4's neighbors right here. We look at 4. 4 has a neighbor at spot 5. So our 5 goes onto the queue. Excuse me, not our queue. 5 goes on to our connections, excuse me please, that are a lovely set of values that we're going to look at. We're going to look at 5 on there, and we're going to say, okay, fantastic, we're going to go ahead and loop over that lovely loop. Have we visited 5 before? No, no we've not. So we're going to put 5 on there, we're going to print the contents of 5, and then 5 is the arrow symbol, is the return operator for methods in Swift. So we have that right there. So we have this lovely thing now set to be true on that. And so then at that point, we're going to put 5 onto this lovely queue because we add it out of that because we've actually added it to the our lovely queue. We pushed it on there. We're then going to go up, and our queue is not empty. We took 4 off because 4 is the lovely one we got the 5 on. We should have popped that off already. So we're going to then go to the next one, which is 5. 5, we grab its neighbors, and we have on a neighbor for 5, we have 4. We look at 4. Have we already visited 4? Oh, yes, we have. So we don't have to do any of that stuff. We're out of that one. We're gone. So that one gets popped off. 6 is gone as well. We look at 5 right here, and 5 is on there, and we're popped that off, and we are good. So 6 actually had 2. We checked that. That's already out. 5 goes out. 5, we're out. We're out there. And we have our contents of our graph printed off. We're done. The graph traversal with the lovely breadth first traversal has been finished.